Welcome to this presentation, still under the CGH series and on the angle trisection solutions. In this video, we are going to learn how to see the trisection of 45 degrees using the Alex's method or the Alex-Kimwea algorithm. As I've just performed in the previous presentations, in this video I'm going to use the GeoGebra software to carry out this process. And this is where I open it from. There we are in the GeoGebra environment or GeoGebra geometry environment. I first prepare the necessary tools for use in the process. I raise the tool center. Okay, I can preserve that. I'll need that. Yes, possibly that. And this is okay. I'll need the compass tool. I raise that. And another important tool that may be highly used is that for the geometric transformations. I create my 2 points, my 2 arbitrary points on the plane, like point A and point B. From here I want to generate 45 and then perform the trisection of 45 using Alex's method. I need to drop that. So I reflect point A about point B. There are 2 ways I can drop or construct the perpendicular through point A. One of the ways is using this tool. I need to use this tool again, the compass tool, just to make sure I'm within the 60 degrees configuration. The 3rd degrees configuration in the first place. So before anything else, I need to construct 30 for security measures or purposes, as I've just been saying. And this is how I'm performing the construction of the 3rd degrees. So I give this a different color for distinction purposes, and as usual I'll give that one I've used in the previous presentations. Now I can make my 45 by bisecting this 90 EAB 45. You realize that 45 degrees angle is above the 3rd degrees configuration. So what do we do? As we have done in the previous presentation of trisecting angles above the 3rd degrees configuration, we reduce this one to its submultiple angle within this set. And this is how I do that. Enable this. Use the angle bisector tool or bisection tool to construct the bisection of that angle at that point, and we are within the 3rd degrees configuration. Here now I can perform the trisection process, and to do that I label this. I'll use the line segment to join the points G and B. That's actually the segment of major interest through the process. I can label this as, I'm giving it that color. Alright, choose, that is better, just for clarity. Now we already have one of the conditions working. The other one is to construct the midpoint of this ray AB that way. Using this tool I need to map this, the geometry transformation tool, and to map the point H into H prime about point A. And now we set to initiate the trisection process. And this is how I do it, as I've just done in the other videos. You can see I've not dropped the straight line from point G through point H prime, and that may picture a different image of not knowing exactly how to trisect a line, but being in the software you can do the trisection from many dimensions. So I give that line that color because it carries some characteristic features to other lines I would like to generate. And I'm going to use the segment or the code AI. Place it there. Again, carry AI. at that point. These I can give them a different color for just clarity. I have that, this, I have that. That's fine. I can now label this as point, sorry, not well placed, point J, not well placed. It should not highlight the bluish color. And here I zoom in so that I can accurately and confidently label this point of intersection here between the curves of the trisection curves. Now with that, I need to construct two lines parallel to the line H prime G, and starting from point A through point G, I have one of the lines. From H through point K, I have the other line. I have trisected the chord BG under that condition, under those conditions. This is so parallel, I give it the same color. Now I'm doing the magnification so as to be able to label the trisection point correctly on this line. It's well placed. I zoom out to drop the other point for good labeling. It hits, and zoom out completely everything to perform the final step. The final step requires I draw a straight line through point H prime into the point M, and the other one should go through point, the last point is L. So from point A through L, and there it is. I zoom in the figure so that I can get to the points of intersection between the last set of lines and the external curve, this curve. Smooth slightly to give me this, not that point exactly. I need to zoom out to avoid these mistakes, give wrong results. That can be well labeled, I suppose. There it is. So I have NO as the last points, and these are the these obtained. They carry the anchor I'm interested in. I can pick the chord NO from here, 2 points, and place it here. That is it. I can give that this kind of color. I will need to label here this point as point P. Now we bisected the 45 degrees, so I need to stroke this twice. Around here, just pick that way. Since it's the same thing, this I also give it the same appearance, and that shows if I'm sure of having trisected the 45 degrees angle, then this angle should be a third of 45. And give it red. The 45 is here. I can give this Mr. Red too. I'm sure it's that one. When I measure this, it should be at 15 degrees. And you can look at the angle produced up here, that is 15. I want to be in the scale 0 to 180. And that is it. And you can proceed to perform the proof using geometric comparisons as I've just shown. In the article on the angle trisection solution, a lot of discussion is provided on how we arrive in this kind of proof. It's actually a conditional proof. This is one of the best ways to show trisection of quantities, angles geometrically. Another proof using trigonometry, that is not geometry and it is just wrong. Another proof using whatever kind of analysis may not be exactly geometry. So this is the best way of justifying this results. That is it, 15. So I have just trisected 45 and using Alex's method. This is the last set of videos in the playlist on the angle trisection solution. I hope to have responded to many questions I have received from different readers of my articles. Why can't you produce videos to show us this method? It is appearing complex. It's actually the shortest method I have seen or come across from myself and through the internet, through many books I have read. No other human has come up with this kind of construction. The shortest. You'll find so many on the internet, some going to over 200 steps. Honestly, it would be so difficult to teach such procedures at high schools and lower primaries. Mine can be gone, or can be well cascaded down to the lower levels of education, through universities to secondary schools or A level. Study courses. So that is that with construction of, with the trisection of an arbitrary angle and a particular angle. I hope the presentation would have responded again to the misconception idea that if we are able to construct all the whole number angles, we should be able to trisect any angle. That is not the case, but as you have seen, it's possible to work from the other side. If we are able to trisect any given angle, we then should be able to trisect all the whole number angles. It's also possible to use trisection techniques to generate the other methods we are interested in, or any other angle, like angles multiples of 5. If we use protractor to measure, suppose there was no algorithm for construction of all the whole number angles, and we measure an angle like 45, we can trisect it, 48, we can trisect it and we get all the angles multiples of 2 and so on, using this method. It's so interesting, and not just something here, but it's actually one of the best methods to exist to this date. It's working under the 3 postulates of Euclidean geometry. It has obeyed all the conditions. It has not violated any condition. In terms of accuracy, for those who would need to know the accuracy, it's good up to that decimal place is okay, we have seen, and that's what has been used conventionally. If you go to 15, you can get some accuracy errors, like up to that. So this is practically a good procedure and the best to exist today. I hope those using the methods are enjoying, and after seeing this video, they will have gotten much light on the procedure or the described construction. The conditions are simple. 1, for the proof, we employ this. This is the only best way I understand, and as it was used by communities, although it did not have the ideas of this idea at hand, it's one of the techniques that can help generate these results and act as proof, because it's about comparisons. If, for example, I stroke this curve, the segment along this curve, it's first going at 15, it can go even to 30, from 30 I go to 45, so it will just go exactly 3 times. It's about comparison. I carry it again as I place it here at 45. It makes a, let me put this into a different, let me pick this blue for demonstration. I do not speak theoretically in everything. This is how we can show these things are doable. So I pick again the same segment or chord, and assuming here, this is 30, it appears to cut here, they intersect at a common point. So that is it. That's how you can do the comparison, and one of the best ways without just stroking along the curve is to work with these properties. To work with these properties, there's this line segment, this line segment, this line segment. Here, this is likely to produce an isosceles triangle. I have just described that in my proof and how this comes up. Enjoy reading the articles. In case of any difficulties, feel free to contact me through the provided details in the research paper. Well, that's the end of this presentation and the videos in the playlist on the angle trisection solution. We have seen what has been hidden for over 4,000 years in this century. Thank you very much for viewing this video. Kindly feel free to like and subscribe to this channel so as to be updated on videos and the other items as we listed in the contents of the introductory video of this presentation. Thank you very much once again.